Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on the volume of a pyramid. If you need any extra help in finding the volume of a pyramid, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video number 360, there's a dedicated video tutorial there on finding the volume of a pyramid. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one, we're told that here's a pyramid, and the height, the perpendicular height of the pyramid is 7 centimeters, and the area of the base of the pyramid is 60 centimeters squared. And we've been asked to find the volume of the pyramid. So the volume of a pyramid is equal to a third the area of the base times the perpendicular height. So the volume is equal to a third times the area of the base times the height. Now in terms of this pyramid, we know the area of the base is 60, so that means the volume will be a third of 60 times the perpendicular height, which is 7, so multiply by 7. And if we do a third of 60 multiplied by 7, that'll tell us the volume of this pyramid. And a third of 60 is 20, and then we're going to multiply by 7. And 20 times 7, well, 2 times 7 is 14, so 20 times 7 would be 140. So it's 140 centimeters cubed, and that's the volume of that pyramid. Okay, let's look at our next question, question number 2. So question number 2, we're told a rectangular base pyramid is shown below. So this is a rectangular base pyramid. You can see the base of the pyramid is a rectangle, 8 centimeters by 6 centimeters. And the perpendicular height of the pyramid, the height from the base to the highest point, is 9 centimeters. And we've been asked to work out the volume of the pyramid. So the volume is equal to a third the area of the base times the height. So a third times the area of the base. Well, to get the area of the base, we're going to do the length multiplied by the width because it's a rectangle. And length times width, that's going to be 8 times 6. So 8 times 6. And 8 times 6 is equal to 48. So the area of that base is 48 centimeters squared. So that means we're going to do, for the volume of this pyramid, we're going to do third the area of the base, and the area is 48, so 48, and then multiply by the height of the pyramid, which is 9. So we just need to do a third times 48 times 9, and then that'll be the volume of that pyramid. Now in terms of doing this, we could do it in a few different approaches. We could do a third of 48, and that's equal to 16, and then times 9. Or we could do a third of 9, which is 3, and then do 3 times 48, and then that'll give us the answer. Or you could do 9 times 48 and then divide by 3. I probably would do a third of something. I probably would do a third of the 9. So a third of 9 is equal to 3. So a third of 9 is equal to 3. And then I'm going to do 3 times 48. So if I do 48 multiplied by 3, let's see what we get. 3 times 8 is 24. Put a 4 down and carry our 2. 3 times 4 is equal to 12, plus 2 is equal to 14. So that'd be 144. So a third of 9 is equal to 3, and then times by 48 would be equal to 144 centimeters cubed. So the volume of that pyramid is 144 centimeters cubed. Okay, let's look at our next question, question number 3. So question number 3 says a square base pyramid has a base with a side length of 15 centimeters. So because it's a square base pyramid, that means that the length and the width of the base are both 15 centimeters because it's squared, the length and the width are the same, so it's both 15 and 15. And the perpendicular height of the pyramid is 10 centimeters. So the height from the base up to the highest point is 10 centimeters. And we've been asked to calculate the volume of the pyramid. So the volume of the pyramid would be equal to a third the area of the base times the height. So we're going to do a third the area of the base, well, the base is a square, and to find the area of a square, we just do the length times the width, so that's going to be 15 times 15. And 15 times 15, it's a non-calculator question, so I'm going to do 15 multiplied by 15. And I already know that's 225, but let's have a look at it. 5 times 5 is 25, put a 5 down, carry a 2. 5 times 1 is equal to 5, plus 2 is 7. Now we're going to multiply by 10, so put a 0 down. 1 times 5 is 5, and 1 times 1 is 1. So we now just need to add these together. 5 plus 0 is 5. 7 plus 5 is 12, put a 2 down and carry a 1, and 1 plus 1 is equal to 2. So the area of the base, if it's a square base pyramid and the side length of the square is 15, 15 times 15 is 225, so the area of the base is 225 centimeters squared. So it's a third, the area of the base, which is 225, times the height of the pyramid, the perpendicular height of the pyramid is 10. So we now just need to work this out now. So we need to do a third of 225 and then multiply by 10 or times them together and then divide by 3. So I'm going to do a third of 225 to begin with. So 225 divided by 3. How many 3's go into 2? 0 remainder 2. How many 3's go into 22? That's 7 remainder 1. And how many 3's go into 15? That's 5. So that's 75. So a third of 225 would be 75. So we've got 75 multiplied by 10. And 75 times 10 is 750. So it's 750 centimeters cubed. So that's the volume of that pyramid. So just to recap, so we found the area of the base by doing 15 times 15, which is 225. We then done a third the area of the base times the height. We done a third of 225, which is 75, and then times by 10 to get 750. So the volume of that pyramid is 750 centimeters cubed. Okay, let's look at our next question, question number 14. This is a calculator question, so that's quite nice. We can get our calculator. And we want to find the volume of this pyramid, and it's a square-based pyramid, so it's a square-based pyramid. So let's find the volume of the square. So in terms of the square, we know that this length is 17.5 centimeters, and that means that that length would also be 17.5 centimeters. And if we want to find the area of the base, we're going to do 17.5 multiplied by 17.5. And it's a calculator question, so that's quite nice. 17.5 squared, or times itself, is 306.25 centimeters squared. So that's the area of the base. Now we want to find the volume of the pyramid, so we're going to do the volume is equal to a third the area of the base times the height of the pyramid, which is 19.1. So we're going to do a third multiplied by the area of the base, which is 306.25, multiplied by the height of the pyramid, which is 19.1. And then if we just type that into our calculator and type in a third times by 306.25 multiplied by 19.1, that's equal to 1,949.791667 centimeters cubed. And that's the volume of that pyramid. And we haven't been asked to round it to so many decimal places, so you could just leave it like that. Or I'm going to round it to one decimal place. I'm going to write 1,949.8 centimeters cubed to one decimal place, to 1 dp. And that's it. Okay, let's look at our next question. Okay, so question number 5. So question number 5, we've got this pyramid, and we've got A, B, C, D, E is a pyramid, and M is the midpoint of AC. So that diagonal, AC, M is the midpoint. So, and that's directly beneath the vertex of the pyramid, E. And we've told some of the measurements here. We're told that AB, so from A to B, is 1.3 meters, so 1.3 meters. We've got the BC, so I'm going to write 1.3 meters. The distance from B to C is 90 centimeters, or 0.9 meters. I'm changing them all to meters here. And the ME, the perpendicular height of the pyramid, is 1.45 meters. So we need to find the volume of this pyramid. So the volume is equal to a third the area of the base times the height. So let's find the area of the base. So the area of the base is a rectangle, so we're going to do 1.3 multiplied by 0.9. And if we do 1.3 multiplied by 0.9, that's equal to 1.17. So the area of this base is 1.17 meters squared, or 1.17 square meters. So in terms of the volume, we're going to do that's equal to a third times the area of the base, which is 1.17, multiplied by the height of the pyramid, which is 1.45. And then we just need to type this into the calculator. So a third multiplied by 1.17 multiplied by 1.45 is equal to 0.5655 meters cubed. And that's it. That's the volume of that pyramid, 0.5655 meters cubed. And that's it. If you had have worked in centimeters rather than meters, you would have got 565,500. Actually, I'll just write that down in case you've done it that way. So you would have got 565,500 centimeters cubed. And that's what you would have got if you changed these measurements into centimeters. So 130 centimeters and 145 centimeters, and worked out the question that way. Or if you know what the answer is in meters cubed and you wanted to convert to centimeters cubed, you multiply by a million, because you're timesing by 100, 100, and 100 again. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 6. So question number 6 says a triangular base pyramid ABCD is shown below. We're told that AB is equal to 4 centimeters, AC is equal to 5 centimeters, and BC is equal to 3 centimeters, and also that AD is equal to 6 centimeters. So this is a right angle triangle on the base of the pyramid, and the perpendicular height, the height from the base up to the highest point of the pyramid, is 6 centimeters. And we've been asked to calculate the volume of that pyramid. So the volume is equal to a third the area of the base times the height. So we know the height's going to be 6, so that's going to be a third multiplied by the area of the base, which we need to find, multiplied by 6. Now we just need to find the area of the base. So in terms of the base of the pyramid, it's a triangle, it's a right angle triangle. And here we've got the base of the triangle. If we were looking at it this way, the base of it would be 3 centimeters, and the height of the triangle would be 4 centimeters, and the 5 is a diagonal. Now when you're finding, actually let's just sketch this triangle. You've got here the triangle looking like this. Now you could draw it slightly differently, but I've done A, here, B here, and C here. So this is the 4 centimeters there on that side. We've got 3 centimeters on the base there, and then that diagonal, that 5 centimeters is there, and then that's the right angle. So if we want to find the area, we would do the area is equal to half the base times the height, because it's a triangle. So we do half the base times the height, so it's a half of the base, which is 3, times the height, which is 4. Now 3 times 4 is equal to 12, and half of that is equal to 6, so 6 centimeters squared. So the area of that triangle is 6 centimeters squared. So that means the area of the base is 6. So that means if we want to find the volume of this shape, we're going to do a third times the area of the base, which is 6, times the perpendicular height, which is 6. 6 times 6 is equal to 36, and then times by a third is equal to 12. Or it's a calculator question, you could do it on your calculator, but we've got an answer of 12 centimeters cubed. And that's it, that's the volume of that pyramid. Okay, let's look at our next question, question number 7. So question number 7 says, calculate the volume of a pyramid that has a square base of side length 2.9 centimeters and a perpendicular height of 5 centimeters. So that would be the volume is equal to a third the area of the base times the height. So the area of the base, well, it's a square base pyramid, so we're going to do for the area, it would be 2.9 times 2.9, so 2.9 multiplied by 2.9. And let's work that out. So 2.9 multiplied by 2.9 is equal to 8.41 centimeters squared. So that's the area of the base. So we've got the volume would be a third. The area of the base, the square, is multiplied by 8.41 multiplied by the height of the pyramid, which is 5. And then if we just work that out, so times by 5 and times by a third, and I'm just doing this in my calculator, I get an answer of 14.016666 and so on. And I'm just going to round that. I'm going to round it to 3 decimal places. So that'll be 14.017 to 3 decimal places. And that's it. Okay, let's have a look at our next question, question number 8. So question number 8 says that shown is a solid that is made of a pyramid on the top and a cuboid. And we've been asked to calculate the volume of the solid. So we need to find the volume of the cuboid and then the volume of the pyramid and then add them together, and then that'll be the volume of the solid. So let's start off with the cuboid. That's quite straightforward. So in terms of the cuboid, the volume of a cuboid is equal to, volume is equal to the length multiplied by the width multiplied by the height. The length, that's 5, the width is 4, and the height is 4. So it's going to be 5 times 4 times 4. And 5 times 4 is equal to 20, times 4 is equal to 80, so that's 80 centimeters cubed. So that's the volume of the cuboid. Now let's get the volume of the pyramid. So the volume of the pyramid is equal to, the volume is equal to a third, the area of the base times the height. So in terms of the area of the base, so if we have a look at the pyramid on the top here, if this length here is 5 centimeters, this length here is also 5 centimeters. And if this length is 4 centimeters, that length would be 4 centimeters. So it's going to be 5 centimeters and 4 centimeters, and 5 times 4 is equal to 20. So the area of the base of that pyramid would be 20 centimeters squared. So it's going to be a third multiplied by 20, the area of that base, 5 times 4, I'm just going to write that down, the area would be equal to 5 times 4, which is equal to 20 centimeters squared. That's the area of the base of the pyramid. And then the height, we need to multiply by the height. Now in terms of the height of the cuboid is 4, and the height of the whole thing, the whole solid, is 6. So if we do 6 take away 4, 6 take away 4 is equal to 2. So that means the height of the pyramid would be equal to 2 centimeters. So multiply by 2. So we just need to do a third, multiplied by 20, multiplied by 2, and that gives us the volume of the pyramid on top of the cuboid. So let's do that. And that's equal to 13.333 and so on centimeters cubed. So we've now got the volume of the cuboid, 80 centimeters cubed. We've got the volume of the pyramid, which is 13.333 and so on centimeters cubed. We just need to add them together. So 80 plus 13.333 and so on is equal to 93.333 and so on centimeters cubed. So 93.33 centimeters cubed to 2 decimal places. And that's it. That's the volume of that solid. Okay, let's look at our next question, question number 9. So question number 9, we've been given a pyramid and we've been given the volume of the pyramid. The volume of the pyramid is 126 centimeters cubed. And we need to find the height of the pyramid h. We want to find the perpendicular height of the pyramid. So let's do that. So the volume of a pyramid is equal to a third multiplied by the area of the base multiplied by the height of the pyramid. So the volume this time we know is 126. And then we're going to do a third multiplied by the area of the base. So the base, well, is a rectangle, and we're going to do 9 times 7, so that's 63 centimeters squared. So that's the area of the base of the pyramid. So a third times 63 times h, the height of the pyramid. So let's work this out. So we've got 126 is equal to a third of 63. Well, 63 divided by 3 is equal to 21 multiplied by h. And then if we do 126 divided by 21, That's equal to 6. So the height of the pyramid is 6 centimeters, and that's it. The height of that pyramid is 6 centimeters. So in this question, what we done was we were given the volume. So we substitute that into the formula. The volume is equal to a third the area of the base, which is 63, times the height. And then we just worked it out, and we found the height of the pyramid was 6 centimeters. Okay, let's look at our next question, question number 10. So question number 10 says, shown as a square base pyramid with a volume of 270 centimeters cubed. And we know the perpendicular height of the pyramid is 10 centimeters, and we want to find the side length of the base x. So let's do that. So the volume of a pyramid is equal to a third the area of the base times the height. So the volume is 270, and that's equal to a third times the area of the base. Now, if it's a square base pyramid, if that side's x as well, and we would do x times x, which is x squared. So the area, if we do multiply by x squared, just trying to make my multiplication sign, and the x look different there, multiply by the height, the perpendicular height, which is 10. So we've now got this, we just need to solve this, and then we'll find out what x is. So I'm going to divide both sides of this equation by 10. So dividing the left-hand side would be 27. And dividing the right-hand side by 10 would get rid of this multiply by 10. So we just have a third times x squared. So to solve this, we could use a couple of approaches. One approach is to divide both sides of the equation by a third. So divide by a third and divide by a third. Now in one whole, there's 3 thirds. So in 27, there would be 81 thirds, so 81. And then on this side, if we divide by a third, we get rid of the multiply by a third. So we're just left with x squared. So that's one way to approach it. Alternatively, we could have just multiplied both sides of the equation by 3, and you'd get 81 on that side. And multiplying by a third by 3 would be 1. So you'd just be left with the x squared. And then finally, we know that x squared is equal to 81. So that means that x would have to be equal to 9. The square root of 81 is equal to 9. And here it's the length of a side, so it's going to be 9 centimeters. So that means that x is 9 centimeters. So let's write that down, 9. So that's 9 centimeters. And that's it. Okay, let's look at our next question. So question number 11. Question number 11 says a solid wooden paperweight is shown below. And the paperweight is a rectangular base pyramid. So we've got this rectangular base pyramid, and the density of the wood is 0.65 grams per centimeter cubed. So every centimeter cubed has got a mass of 0.65 grams. So we find the volume of this. If we then just multiply that by 0.65, we can find the mass of the paperweight. And that's what we've been asked to find, the mass of the paperweight. So let's find the volume. The volume will be equal to a third the area of the base times the height. So the base is a rectangle, and we would do 8 times 7, and 8 times 7 is equal to 56. So the area of the base is 56 centimeters squared. So the volume of this pyramid would be a third times the area of the base, which is 56, times the height of it, which is equal to 6 centimeters, so 6. And then let's just work this out. It's a calculator question, so I'm just going to do 56 times 6, and then multiply that by a third, and that's 112 centimeters cubed. So that's the volume of the paperweight, 112 centimeters cubed. And because the density of the wood is 0.65 grams per centimeter cubed, that's the density of the wood, this is a solid wooden paperweight, each centimeter cubed has got a mass of 0.65 grams. So if we do 112 multiplied by 0.65, that'll tell us the mass of this paperweight. So 112 multiplied by 0.65 is equal to 72.8 grams. So that's the mass of the paperweight, 72.8 grams. And that's it. Okay, let's have a look at our next question, question number 12. So question number 12 says that DEFG is a triangular base pyramid, and the base DEF is an equilateral triangle with side length 6 centimeters. And the perpendicular height of the pyramid is 4 centimeters. And we've in this question been asked to calculate the volume of the pyramid. So to find the volume of the pyramid, the volume is equal to a third the area of the base times the height. Now we know the height's 4, that's quite straightforward, but the area of the base. So we've got this equilateral triangle DEF. So this side length is 6 centimeters, this side length would be 6 centimeters, and this side length would be 6 centimeters. I'm actually just going to sketch that triangle now. So that's a little sketch. And here we've got 6 centimeters, 6 centimeters, and 6 centimeters. And 6 centimeters. So they're the lengths of the 3 sides. So we want to find the area of this triangle. So in terms of the area of this triangle, we want to do half the base times the height. Now the base is straightforward, but we want to find the height of the triangle. So we want to find the height h of that triangle. So to find the height of the triangle, that's a right angle triangle. We've cut this triangle in half, so if that's 6 centimeters, this side will be 3 centimeters, and that side will be 3 centimeters. And we've got the hypotenuse, the longest side opposite the right angle, is 6 centimeters. So we're going to use Pythagoras' theorem here on this little triangle on the left-hand side, or on the right-hand side, to find the height of the triangle. So the longest side is the one opposite the right angle. So actually remember, Pythagoras' theorem is a squared plus b squared equals c squared. So A and B are the two shorter sides, and for this right angle triangle here, the two shorter sides would be 3 and h, and the longest side would be the 6. So let's substitute in the values. So instead of a squared, we've got 3 squared, plus instead of b squared, we've got h squared, and instead of c squared, the longest side, that'll be 6 squared. 3 squared is 9, so we've got 9 plus h squared equals 36. And then if we take away 9 from both sides, so take away 9 and take away 9, we'll be left with h squared equals 27. So that means that h is equal to the square root of 27. And the square root of 27, if we work that out, the square root of 27, that's equal to 3 root 3 or 5.196 and so on. Now here, because we want to find the area for this triangle, so this triangle here, the area would be equal to half the base times the height. So half the base, and the base is 6, the whole triangle, the half of the base would be 6, so half of 6, multiplied by the height of the triangle. Now we could write down our 5.196 and so on, but I'm just going to leave it as the square root of 27. So let's work this out, and that'll be the area of that triangle. So if we multiply that by 6 and by 0.5 or half, so we get an answer of 9 root 3 centimeters squared, or as a decimal number be 15.588 and so on centimeters squared. So here we could actually use 9 root 3 centimeters squared for the area of the base of the triangle, or 15.588 and so on, and write the whole calculator display down. So this is fantastic. We now know the area of the base of the pyramid. It's 9 root 3 centimeters squared, or 15.588 and so on. So that means the volume of the whole pyramid would be equal to a third multiplied by the area of the base, which is 9 root 3, or you could use 15.588 and so on, multiplied by the height of the pyramid, which is 4. So let's work this out. So a third multiplied by 9 root 3 multiplied by 4 is equal to 12 root 3, or as a decimal number, because we're finished now, 20.784609 and so on centimeters cubed. And I'm just going to round this. I'm going to round it to 3 decimal places, so that'll be 20.785 centimeters cubed. And that's it. That's the volume of that pyramid. Okay, let's have a look at our next question, question number 13. So question number 13 says the square base pyramid 1 is divided into 2 parts, a square base pyramid 2 and frustum 3, as shown below. So this pyramid is split up into that pyramid, a smaller pyramid, and this frustum. So really what's happened is the top's been chopped off. And then the question says pyramid 1 has got a base of side length 8 centimeters, that's 8 centimeters and 8 centimeters. Pyramid 2, this one here, has got a base of side length 4 centimeters and 4 centimeters. And we're told the perpendicular height of pyramid 1, the perpendicular height of this pyramid, is 10 centimeters. And the question says, calculate the volume of frustum 3. So we want to find the volume of that frustum. So what I'm going to do is I'm going to find the volume of this pyramid, and I'm actually going to find the volume of that pyramid. And because these two pyramids are mathematically similar, they're enlargements of each other. When you chop that smaller pyramid from the top of the pyramid, it's going to be a smaller version of the larger pyramid. So it's mathematically similar. It means the bigger one's an enlargement of the smaller one. So here, if this is 8 centimeters and that's 8 centimeters, and this is 4 centimeters and 4 centimeters, the lengths have been divided by 2. So if the height of the whole pyramid is 10 centimeters, that means the height of this pyramid is 5 centimeters, because it's half the height. So if we find the volume of this pyramid and we find the volume of this pyramid, if we take the volume of the smaller pyramid away from the volume of the larger pyramid, what's left would be the volume of the frustum. So let's do that. Let's find the volume of pyramid 1, the volume of pyramid 2, take the volume of pyramid 2 away from the volume of pyramid 1, and you're left with the volume of the frustum. So let's do that. So let's start off with pyramid 1. So pyramid 1. So we've got the volume is equal to a third, the area of the base times the height. The area of the base would be 8 times 8, that's 64 centimeters squared. That's the area of the base, so a third of 64, multiplied by the height of the pyramid, which is 10. And then when we work that out, that'll be the volume of that pyramid. So that's going to be 64 times 10, and then divided by 3 is equal to 213.33 recurring and so on centimeters cubed. So that's the volume of that larger pyramid. Let's find the volume of this smaller pyramid, so pyramid 2 now. So the volume is equal to a third, the area of the base times the height. So that's a third. The area of the base, 4 times 4 is 16 centimeters squared. So it's going to be a third times 16 times the height of the pyramid, which is 5. 16 times 5 is 80, and divided by 3, 80 divided by 3 is equal to 26.66 and so on centimetres cubed. So we've now got the volume of the larger pyramid and the volume of the smaller pyramid. If we take the volume of the smaller one away from the bigger one, that'll be the volume of the frustum. So we're going to do 213.3333 and so on, subtract 26.666 and so on, and that's equal to 560 over 3, or 186.666 and so on centimetres cubed. So that means the volume of the frustum, let's round the two decimal places, that'll be 186.67 centimetres cubed. That's the volume of that frustum, and that's it. Okay, let's have a look at the next question, question number 14. So question number 14 says that HIJK is a triangular base pyramid, and that the base HIJ is an equilateral triangle with side length 10 centimeters. So as you can see, HJ is 10 centimeters, IJ would be 10 centimeters, and HI would be 10 centimeters as well. And the volume of the pyramid is 300 centimeters cubed. And we've been asked to calculate the perpendicular height, h, of the pyramid. So we want to find the height of the pyramid. So we know that the volume is equal to a third the area of the base times the height. So in terms of the volume, and that's equal to 300, and that's equal to a third the area of the base, which would be what we need to find, the area of the base, the area of that equilateral triangle, HIJ. And then we're going to multiply that by the perpendicular height of the pyramid, h, and that's what we want to find out. So let's work out the area of the base of this pyramid, so HIJ. So that's an equilateral triangle with side length 10 centimeters. So I'm just going to sketch an equilateral triangle here. And in terms of the equilateral triangle, we know the side length is 10 centimeters. That's 10 centimeters, 10 centimeters, and 10 centimeters. And that's 10 centimeters. And we want to find the area of this equilateral triangle. So we're going to do half the base times the height. So let's find the height of this equilateral triangle. And I'm going to label that y. So we want to find the height of this equilateral triangle, and then we can do half the base times the height of the triangle to find the area at the base of the pyramid, the area of that triangle. So let's find out what y is. So we've cut this into two right angle triangles. We've cut the base in half, so that's 5 centimeters there and 5 centimeters there. So here we've got a right angle triangle. We've got the length of the longest side being 10. We've got the two shorter sides being y and 5. So that means that a squared plus b squared equals c squared. So a squared, that's going to be one of the two shorter sides, so let's call that 5 squared, plus b squared, let's call that y squared, and that's equal to the longest side, which is 10 squared. 5 squared is 25, plus y squared, that's just y squared, is equal to 100. And now if we take 25 off both sides of that equation, we'll be left with y squared equals 75, just taking 25 away from both sides. And that means that y will be equal to the square root of 75. So that means that y is equal to root 75. So now we can find the area of this triangle, because the area will be equal to half the base times the height. The base of the triangle is 10, so that's a half of 10 times the height of the triangle, which is y, which is root 75. And then if we work this out, that'll be the area of the triangle. So let's do that. So half of 10, that's 5, times the square root of 75 is equal to 25 root 3, so 25 root 3, or as a decimal number, 43.301 and so on centimeters squared. So that's the area of the equilateral triangle, and that would be of the area at the base of the pyramid. So I'm just going to write it down here, and instead of calling it 43.301 and so on, I'm just going to use 25 root 3. So 25 root 3, that's the area of the base of the pyramid. So here we can put this in here. So the volume was 300, and that's equal to a third times the area of the base, which is 25 root 3, multiplied by the height, h. So we've now got this, we can solve this to find h, the height of the pyramid. So the first thing I'm going to do is I'm going to multiply both sides of the equation by 3. I could divide by a third, but that's the same as multiplying by 3. So 300 times 3 would be equal to 900. A third times 3 is equal to 1, that's why I'm doing it, to get rid of that third. And then that's equal to 25 root 3 times h. And now we just need to do 900 divided by 25 root 3. So we're going to divide both sides of the equation by 25 root 3. The right hand side would just be h, and the left hand side 900 divided by 25 root 3 is equal to 12 root 3, or as a decimal number, 20.7846 and so on. And I'm going to round that, I'm going to round it to 3 decimal places, so that's 20.785 centimeters. And that's it, that's the height of that pyramid. Okay, let's have a look at our next question, question number 15. So question number 15 says, Hannah created a glass paperweight, and the apex of the pyramid, I, is directly above the centre M of ABDC. So the apex is directly above the center of the base. And then we're told the density of the glass is 2.6 grams per centimeter cubed. So every centimeter cubed of this glass has a mass of 2.6 grams. And the mass of the paperweight is 1,705.6 grams. And the question says, find the height of the paperweight, IM. So we want to find this height, IM. Okay, so first of all, let's find the volume of the paperweight, because we know the mass of the whole paperweight, which is 1005.6 grams, and we know the density, which is 2.6 grams. Now we know every single centimeter cubed has got a mass of 2.6 grams, so if we divide by 2.6, that'll tell us the volume of this paperweight. So 1705.6 divided by 2.6 is equal to 656 centimeters cubed. So that's the volume of this paperweight. Okay, so let's have a look at this cuboid. The cuboid has got dimensions 12 centimeters, 10 centimeters, and 5 centimeters. So for the cuboid, if we do 12 times 10 times 5, that's going to be the volume of the cuboid. 12 times 10 is equal to 120 times 5 is 600. So that's 600 centimeters cubed. So that's the volume of the cuboid. So now if we take away the volume of the cuboid from the total volume, that'll tell us the volume of the pyramid. So let's do that. So for the pyramid, if we do 656, take away 600, that's equal to 56. So that means the volume of the pyramid is 56 centimeters cubed. So that's the pyramid, which is EFGHI, that rectangular base pyramid on top of the cuboid. So let's find, if we consider just the pyramid now, so if we say that that's the height of the pyramid, I'm just going to call that H, that's the height of the pyramid. And we've got this pyramid, which has got here, this length is 12 centimeters. This length here is 10 centimeters. And we've got the height of the pyramid, which is H centimeters. The volume would be for the pyramid, the volume will be equal to a third the area of the base times the height. So the volume is 56, and that's equal to a third times the area of the base. The area of the base of the pyramid, 12 times 10 is 120, so it's 120 times the height H. So if we solve this equation, then we can find out what H is, and then we can add that onto 5, because if this part is H, remember this is just where the pyramid starts. Below that is the cuboid, and the height of the cuboid was 5 centimeters. So here to here is 5 centimeters, and if we get what H is, we can add that on to get the total length of IM. So let's solve this equation. A third of 120 is 40, so we've got 56 is equal to 40H, and if we divide by 40, 56 divided by 40 is equal to 1.4, so H is equal to 1.4. So that's 1.4 centimeters from here to here, the height of the pyramid, and the height of the cuboid was 5, and if we add those two together, 1.4 plus 5 is equal to 6.4 centimeters, and that's what IM is, the height of the paperweight, and that's it. Okay, so question number 16 says that ABCDE is a square-based pyramid. Square-based pyramid, so if that's 16, that's 16. And 16 times 16 is 256 centimeters squared. I'm just getting the area of the base straight away. Okay, and then we're told that AB, so AB is 16 centimeters, that CE, that diagonal there, is equal to 20 centimeters. And then the point E is directly above the center of the base of the pyramid. Actually, I'm just going to move that area of the base for the minute. I'm just going to write that down, that the area of the base is equal to 256. Okay, so here we're told that E is directly above the center of the base, so let's go straight down to the center of the base, which is there. And then we need to, in this question, what have we been asked to find? We want to find the volume of the pyramid. So for the volume of the pyramid, the volume is equal to a third the area of the base, which is 256, and then times the height. So we need to find this height. So if we want to find this height, well, let's have a look at what we've been given. We know this diagonal, so actually if we go across here from A to C, the whole way across in a straight line, that would be a right angle triangle. And we know that the longest side, the hypotenuse, the side opposite the right angle, is 20 centimeters. We want to find H, the height of that triangle there, the height of the pyramid. And so we need to find this length here. And if we can find what length this is from, let's call that M, if we can find the distance from M to C, we can use Pythagoras' theorem to find the height of the pyramid. So let's do that. So let's find out what MC is. So to find out what MC is, Well, here we've got a right angle triangle. ABC is one big right angle triangle. The two shorter sides are 16 and 16, and AC the whole way across is equal to the hypotenuse, the side opposite the right angle. So that means that if we consider that big right angle triangle, we've got that A squared plus B squared equals C squared, and that means that 16 squared plus 16 squared equals AC squared. So 16 squared plus 16 squared equals AC squared. 16 squared plus 16 squared is equal to 512, and that's equal to AC squared. And then if we square root that, the square root of 512 is equal to 16 root 2, so AC is equal to 16 root 2. So the distance from here to here is 16 root 2, or that's equal to 22.627, and so on. So that's the distance from A to C. Now we were looking at this little triangle here, this right angle triangle, so we wanted to find MC. And MC is going to be half of AC. So if we take AC, which is 16 root 2, and we divide that by 2, that's equal to 8 root 2. So that means that MC is 8 root 2. So here we've got a right angle triangle. The longest side is 20. We want to find what H is, and we know that one of the shorter sides is 8 root 2. So let's use Pythagoras' theorem again. And I'm just going to change colour of ink here, and I'm going to use blue. So here, Pythagoras' theorem, A squared plus B squared equals C squared. The two shorter sides of this right angle triangle are H and 8 root 2. So H squared plus 8 root 2 squared is equal to C squared, which is 20 squared. 20 squared is 400, and 8 root 2 squared, and that's equal to, if I square that, I get that's equal to 128. So H squared plus 128 is equal to 400. And then if we take away 128 and take away 128, we'll get the H squared is equal to 400. Take away 128 is equal to 272. So that means that if we square root, H is equal to the square root of 272, which is 4 root 17, or as a decimal number 16.49, and so on. So that means the H, the height of the pyramid, is equal to 4 root 17, or as a decimal number 16.4924, and so on. Okay, so we've now found the height of the pyramid. We can work out the volume of the pyramid, which is what we're trying to find. So we've had to use Pythagoras' theorem twice there. We had to use Pythagoras' theorem to find the length of the diagonal, AC. We halved it to get MC, and then we use Pythagoras' theorem again to get the height of the pyramid, and that's 4 root 17. So the volume of the pyramid is equal to a third times the area for the base, which is, we've done that at the very beginning, 256, because it's 16 times 16, times the height of the pyramid, which is 4 root 17. And then if we times that, we get an answer of, the volume is equal to 1,407.353, and so on, centimetres cubed. And let's just round that. Let's round it to 2 decimal places. That'll be 1,407.35 centimetres cubed. And that's it. And that's it. So in this video, we've looked at the video solutions to the Corbettmaths practice questions on the volume of a pyramid. If you need any extra help on this topic, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video 360, there's a dedicated video tutorial there on the volume of a pyramid. Also, if you look at near there, you'll find the volume of a frustum as well, and that might be quite useful as well. Alternatively, you can scan this QR code. But in this video, we focus on the video solutions to the practice questions. I really hope you found these video solutions useful. If you have found them useful, please like it, and please also subscribe to my YouTube channel, Corbettmaths. Thank you. Cheers. Bye.